All right, so now we're going to move to the last piece of 4-3, which is dividing. So we talked in the warm-up about using that invert and multiply rule. Remember, words like quotient are telling you, hey, to take this thing and divide it by this thing, this fraction divided by the other fraction. So basically on these, what we always want to do is get it written in multiplication first. All right, now I'm going to say this very first problem, I don't love it. I'm going to go through it and show it to you. You don't really have to expect one that's going to be quite this difficult. But again, I think sometimes showing the really sort of tough pieces to it might make some of the other ones a little easier. So we need to, first off, write this just in the correct form. So we're going to have the first part isn't going to change. The bottom part, same thing, nothing to change. But we're going to change to a multiplication problem by inverting this second fraction. So it'll be x squared plus 3x minus 4. And x squared plus 5x plus 4. And at this point, this is now like what we've been doing the last 2 days. We're going to get this in fully factored form and see how things go. Now, what you're going to run into here is parts of this are fairly difficult to factor. Specifically, this one right here. This numerator right here. This is a cubic, and the only way we've learned to factor a cubic up to this point, there are some methods that you'll learn if you take the trig pre-calc class, is we graph it and we look at the zeros. So let me just throw this one in. You probably remember this from last chapter, or hopefully you remember this from last chapter, is we'd put it in and we'd graph it. We'd take a look at where does it cross the x-axis. And we notice that this one just crosses in one spot. It crosses at, I believe that's at -1. -1, it's at 0. But we know it should have 3 zeros, and odds are pretty good that this is going to have multiplicity 3, or it's going to have 2 imaginaries. So one of those things is going to happen. So off to the side here, I'm going to take this, I'm going to divide -1 out of it. So 1, 3, 3, 1, and see what happens. So a little quick synthetic division here. We multiply, and we add, and we multiply, and we add, and we multiply, and we add. And we see this is the leftover quadratic. This would be x squared plus 2x plus 1. And that actually factors. That is, factors of 1 that add to 2 would be just 1 and 1. That's going to factor to x plus 1 and x plus 1. So what we get from this is that this problem is actually just 3x plus 1s, because if -1 is the solution, then x plus 1 would have had to have been the factor. So like I said, this is a tough one to kind of start with, but it is one that we've done before. So we could rewrite this first part as just x plus 1 times x plus 1 times x plus 1, because that is what it does factor to using our graph, our our synthetic division, and our factoring skills after that. Like I said, don't expect ones that are that tough, but doesn't hurt to see it. This numerator should be an easy one to factor. So factors of -4 that add to 3, we would use 4 and -1. So x plus 4, x minus 1. This one here, if you remember this, we saw this on yesterday's notes, where it's kind of like a difference of squares, but it's not really written in the right order. So just to talk about it, if you reordered it and put the x squared part first, it would look like this. And then you can pull the -1 out of it and actually convert it to a difference of squares. And so now you can be like, oh yeah, that's going to factor to x plus 1 and x minus 1. Again, also a fairly tough piece of factoring in this one. And then this quadratic should be an easy factor. Factors of 4 that add to 5 would be 4 and 1. So x plus 4, x plus 1. Definitely a fairly tough problem there in terms of putting all the pieces together. But now we've done the hard part. We're now at the step where we need to write our restrictions and give the simplified answer. Little side note on restrictions here. We have to take into account anything that was ever in the denominator. So to remember that, this is in the denominator, this is in the denominator, but then also when we flip it, this is in the denominator. So we actually got to look at all 3 of these parts. Basically, it's everything but this one. So we need to look at this and all of these to look for any restrictions, because all of those were at some point in a denominator, and we know we can't divide by 0. So x cannot be -1 or +1 or -4. -1 again, so we're good. -4 again, we're good. And +1 again, we're good. So there's 3 numbers that it can't be. But we do have to look at everything that's ever been a denominator. So another little tricky little piece you got to be aware of with these division problems. All right, so now lastly, to the simplifying part. Any common factors we can cancel right out. X plus 1s, X minus 1s, more x plus 1s. And actually, this problem's awesome. It simplifies to just x plus 1 divided by a negative 1. And all that's going to do is swap the signs. So it's going to be a negative x minus 1. And that's what I do like about some of these problems is they're pretty satisfying. Like you take this big mess of a division problem, and a lot of times they simplify to a pretty simple answer. Okay, again, this is a pretty hard example. This is one where all the factoring is fairly difficult, and it can be a little bit challenging to kind of work through, especially the numerator there, and even the denominator there is a little tricky too. Okay. Now there are a couple more here, so let's go ahead and look at them. Let's do A together, and then I'll have you guys try B out. So A, turn it to a multiplication problem right away. So I got my x squared plus my 9x, changing it to multiplication by inverting. So this is going to be 3x squared minus 18x and 6 minus x. All right, so we get to factoring now. We're going to write this as a single big fraction. 1 is just 1. We don't really even need to write it down because we're going to have this part here. So looks like we do have a GCF in this case. Looks like 3x can get pulled out of those, leaving us with x and minus 6. Cool. This also just a GCF. We could pull x out of that, leave us with x plus 9. And then this is one, again, this is just written in the wrong form. Like we want the x first. So this would be, if you were just, I'm just going to rewrite it, it'd be negative x plus 6. And as we've seen before, we don't like that lead term negative. So just like I've done with the other ones, I'm going to pull the negative 1 out of it to write it as x minus 6. And you're going to see why I do want to do this, because now we're going to see we have things that do in fact cancel out. All right. So I'm all fully factored. What are my restrictions? Anything from here, here, or here, because these were both end up being in the denominator. So as we run through this, it's literally everything, because the only thing we don't have to count is this 1, but it didn't have a variable anyway. So we just got to look through every single piece, anything that makes it equal 0. So 0, negative 9, nothing there because there's no x. This would be 6, 0, and 6. So we already got those. We're good there. So those are our restrictions. And then what can we eliminate? X minus 6, x minus 6. See you later. X divided by x is out of here. And then things like 3 divided by negative 1, you can just make that into a negative 3 because that's what that would be. So we would get just this. And there we go. There's our simplified answer. So this is putting together all our skills. It's putting together factoring with the simplifying skills we've been working on the last couple days. All right, try B out. I'll solve it out as well, and you can check and see how you're looking at it. All right, in terms of all the one we look at today, this is, I would say, definitely the easiest one. The reason I say that is just all the factoring is pretty simple here, or mostly done for you already. So this problem, we changed to multiplication by flipping this. And then the only one you actually have to factor is right here. So we factored a 2x out of both of those. And then every other piece is already in factored form. So I took a second and I wrote down my restrictions. Negative 5, 6, negative 5, all restricted values. And then awesome canceling here, the x plus 5s and the x minus 6s, leaving you with just the 2x. So 2x ends up being your solution, and that's it. So some of these definitely are not too bad. Some, like the very first example we do, can be pretty tough. But for the most part, the toughness is entirely determined by how difficult the factoring is. This problem is pretty easy because the factoring is pretty easy. This problem's not too bad. It's got a little bit of weird factoring, but other than that, definitely not. And this problem had pretty tough factoring, making it pretty tough. So keep working with it. Keep practicing the factoring. The way you get better at it is practicing it. Trying to do it, doing more of them. You get faster at it. You get better at your multiples, all that kind of stuff.